We have posted a video on the mechanism of opening and closing of the chloride ion channel Bestrophin. In this video, we will explain how we made the video. We want to compare the open and closed structures of human Bestrophin too. These structures were published by the Yang Lab at Columbia University in 2022. The reference is given at the end of the video. We will examine these structures in the molecular graphics software Pymol. To access these structures in Pymol, we will fetch 8D1G and 8D1H from RCSB Protein Databank. If there is another protein you would like to study in Pymol, this is a good place to find it. We will use the drop-down menu to download these structures. We will first fetch the open state. Then the closed state. First, we will rename these structures. We will now use the command CE_align on the command line to align these structures, which may take around 30 seconds. To manipulate the structures, we use the buttons on the right next to the names of the structures. We can hide or show the structures by clicking on their names. For now, we will just look at the closed structure. To change the representation of the protein, we can click on the S button. First, we will hide everything. Then, we will show the closed structure as a cartoon. We can also change the way in which the protein is colored by clicking the C button. Because Bestrophin is a homopentamer, we're going to color it by chain. We will look at the closed state of Bestrophin from the plane of the membrane. We can rotate it using the trackpad or mouse. If there's a particular image or instance that you would like to return to, you can store scenes. To do this, click Scene, Store, and then F1. Right-click on the scene's name and type in the name you would like instead of the default. To look at Bestrophin down the pore from outside the cell, we rotate the protein 90 degrees around the x-axis. Now we are going to select the amino acids that make up the gate of Bestrophin. To access the amino acid sequence of the protein, click S in the bottom right corner. We want to make a selection of amino acids numbers 76, 80, and 84. And we can do that either by clicking on the amino acids in the sequence or using the command line. We will be using the command line. The command for this is celi space gate comma resi space 76 plus 80 plus 84. The selection appears in the list on the right. We can also use the command line to choose how we display our selection. To show as sticks, type show space sticks, comma, gate. To visualize the side chains, let's zoom in on the gate by typing zoom space gate in the command line. Select the hydrophobic amino acids by using the command cella space hydrophobic, comma, resin, followed by the 3-letter amino acid codes for the hydrophobic amino acids, PHE plus ILE plus LEU plus VAL plus ALA plus PRO plus MET plus TRP. Then turn off the selection using the deselect button. We can color the entire protein blue to represent the hydrophilic amino acids and then color the hydrophobic amino acids gray. To do this, let's color space blue all and then color gray 70, hydrophobic. Now we can measure the distance between the phenylalanines in the pore by going to the top of the window, clicking the Wizard tab, selecting Measurement, and then selecting side chain atoms in the phenylalanines to find the diameter of the pore in angstroms. Let's click the Close confirmation to temporarily hide it and delete the previous measurement. Then click on the Open confirmation. We can repeat the measuring process to once again find the diameter of the pore, now in the open form. To animate the change from closed to open conformations of Bestrophin, we can type the command morph space closed underscore to underscore open, comma, closed, comma, open, comma, steps equals 100. A terminal will pop up once the command is run, but you do not need to type anything into it. The command may take several minutes to run. This process is a bit unpredictable, and we weren't able to get it to work correctly on this computer, but it does seem to work on another computer. This is an example of an incorrect protein morph. Here's an example of a better morph imported from another computer that still has some problems. It's time to look at the calcium binding site of each chain. Let's click on the Open confirmation to show it once again. Now, color the Open confirmation wheat. Type Cella space CA, comma, symbol space CA, which will show calcium. Click on the color for this new selection and color it bright green and show it as spheres. To find the amino acids that interact directly with the calcium, we can type Cella space near CA, comma, by res, all within 4 of symbol CA. This command highlights all amino acids within 4 angstroms of calcium. Now, color these amino acids by element, using the option that colors the backbone carbons blue and show them as sticks. Click on a calcium ion and type center space Cella. Once this is complete, type zoom center, comma, 10. This will provide a good view of the calcium and its surrounding amino acids. To show the oxygens that interact with calcium more clearly, type Cella space oxygen, comma, symbol O, within 4 of symbol Ca. Show this selection as spheres. These are all the elements we use to construct our video on Bestrophin. Thanks for watching, and we hope you learned a thing or two about Pymol.